Locomotion. How animals move. Now, some animals fly, like bats and birds, some slither, like snakes, some inch like worms, and some of them move like we do, like humans, or at least sorta like we do. While bats and birds have wings, and snakes and worms wiggle their muscular bodies to move, some animals have good old legs and feet. These animals, like us, use the muscles in their legs to move the bones in a specific way that lets them move forward. A signal is first sent by the brain that says, walk. This message goes through the nervous system to the muscles in the leg and makes them expand or contract to bend the foot down, raise the knee, move the leg forward, lower the knee, and ankle the foot back down. This complicated sounding series of events is one step. In order to walk, the body has to maintain two legs alternating steps at the same time. If they fall too far out of sync, then you could trip or fall over. And although this may sound complex, it really isn't. Thankfully, taking a single step is so ingrained in our minds that you don't even really have to think about how to do it when you do it. It just comes naturally. However, the tricky part, that is, the part that's more interesting to think about, isn't how walking is done, but how different kinds of walking are done. Plantigrade is the name for how we walk. Plantigrade means to walk on the soles of the feet. This comes from the Latin planta, meaning sole, and gradus, meaning walking. Planta gradus, plantigrade, sole walking. This isn't the only option, though. Dogs, for example, walk on their paws, but these aren't the same as our feet. In fact, a dog walking on its paws is much more like us walking on tiptoes. This way of walking on the toes and not touching the ground with the heel is called digitigrade. Again, grade or gradus means walking, and the Latin root digitus means finger or toe, a digit. So digitus gradus, digitigrade, toe walking. Now you might be thinking, well, if being digitigrade is to walk on your tiptoes, and I can walk on my tiptoes, am I a digitigrade? Well, no, not really. Just because we're able to walk this way doesn't mean that's how we naturally walk. It really isn't efficient for us to walk around on our tiptoes all the time, and our feet really just aren't built for that sort of use. This is why high-heeled shoes aren't comfortable, especially after being worn for a long period of time. There is one other form of walking, though, the unguligrades. We've already talked about walking on the soles of the feet, and about walking on the toes of the feet. So what's next? Well, it's to walk on the nails of the feet. This is one we really can't do as humans. The closest we can get would be a ballerina standing on point. But this really isn't how unguligrades walk. Unguligrades are hooved animals, like horses and cows. A hoof is actually just a big nail, basically. Rather than being thin and at the end of individual fingertips, the nails on an unguligrade are much larger, denser, and purposeful, as they will take the full weight of the animal. Unguligrade comes from the Latin gradus, again, meaning walking, and unguus, meaning nail or hoof. Unguus, gradus, unguligrade, nail walker or hoof walker. So why is all this important to know? Well, there are a few main benefits to this knowledge. First of all, you can identify various animals by the marks they leave on the ground where they've walked. If the dirt is relatively flat and soft, the imprint left by the animal will be preserved for a while in the earth. Heavier animals will leave deeper footsteps, while faster animals will leave distorted or rough footprints. Knowing what to look for in these markings or tracks left behind by an animal can tell you a lot about them. One thing that can be usually identified clearly is how the animal moves. Do you see the imprint of a full foot? Only toes and claws? A large hoof? Are the tracks close together or far apart? These quickly narrow down the options for what sort of animal might have made that track. Also, knowing the similarities and differences between various animals help us know how related they might be. Two animals that are both digitigrades are likely to be more closely related than a plantigrade and an unguligrade. Although, even if two animals move differently, we can still see their relation by the similarities in their bone structures. Animals of all three forms of locomotion have strikingly similar bone organizations, indicating that they likely descended from a common ancestor. Knowing the various ways in which animals move or locomote is very important for determining a lot of things about that animal, whether you can see it or just its tracks.